Right, so we're looking at the relative atomic mass, and this is linked to isotopes. So what are isotopes? So isotopes are atoms of the same element, right? What makes them different? What makes them the same? They have the same number of protons. And what makes them different? They have different number of neutrons. So isotopes are atoms of the same element with the same number of protons but different number of neutrons. Now we're going to look at copper. So if we just take a copy of that, here is copper. Right, what makes it a copper atom? It's got 29 protons. So we've got copper, which is 29. And if you look at this number here, 63.5, that's the relative atomic mass, and we need to calculate that. So let's put copper in, not carbon. Right. You have one isotope which is called copper 63 and another one called copper, which is 29 and 65. So if you measured the percentage, you would get 69.2% copper atoms that are copper 63 and 30.8% which are copper 65. Now we need to work out the relative atomic mass AR, and it's simple. It's much more simple than it looks. What you do, draw a big line and you multiply 69.2 by this relative atomic mass number 63, and then what you do is you add this percentage multiplied by 65, and then we divide it by 100 because we've got 100%. And if you work that out, you will get 6361.6 for the top. If you work the top bit out, the numerator there, and we simply divide it by 100, and if we round it off we get 63 point, it's near enough 6. Oh, need to put 6 there. Right, and what they've done is they've worked it out and they've rounded it off to 63.5. They've done lots more experiments than the data we've got. So the relative atomic mass for copper is 63.5. We calculate it as 63.6. So it's close enough because that's our experiment. So that's how you work out the relative atomic mass. So let's do one more example quickly. So let's draw a line here, and I'll give you another example down here. So we have 3 silicon isotopes, silicon 28, silicon 29 and silicon 30. So they can present their information like this. And the percentages are 92.2, 4.7 and 3.1. So what's the first thing we do? We put AR equals a big long fraction line, and we take this percentage and write it down. So it'll be 92.9, and we multiply it by this number, 28. Then we're going to add it to the next one. So this percentage here, 4.7, times this number here, 29. Then we're going to add it, this percentage here, 3.1, times this number here, 30. And then we're going to divide it by 100 because there's 100%. And then if we work that out, we can round it off to 28.1. So for silicon it's 28.1. And if you look, so I've taken a copy of the periodic table. If you look at silicon, they've left it as 28. So that's good enough for us. Right, that was the relative atomic mass calculation.